Hey guys, welcome to the video for graphing slope-intercept form. We are in Unit 3A. Our essential question is, why are multiple representations important? Multiple representations are important because sometimes it's easier to use some forms and then sometimes it's easier to use other forms. So we're going to learn about three forms in Unit 3, and there are three forms on how to create a linear function or how to write a linear equation or a linear function. And so I'm going to first write them at the top. Now, right now, they're just going to look like random variables. And one of them you have seen before. So you have seen the first one before. But you haven't seen the other two yet. And those are other forms that we'll learn about later on this unit. But I just want to go ahead and show you all three forms for now. And I'm going to remove my keyboard real quick. Okay, so we have three forms that we're going to learn. And in Algebra 1, we only learn three forms for the linear function, and there's really only three forms for linear functions. The first one is slope-intercept form. The second one is point-slope form. And the third form is standard form. So we're going to learn about three different forms and three different ways we can create and draw and write a line. So I just want you to look at all of these forms, and I want you to tell me what you notice. So there's two variables that occur in every single equation, and I want you to take note of what those two variables are. The first variable that we see in every single equation is y. There's a y here, there's a y here, and there's a y in the third form. So there's a y in every single form. There's also an x in every single form. So in every single form here, I have a y and I have an x. So for every linear equation, I'm always going to have an independent variable and a dependent variable. So I only have an x and I only have a y. Or not only, but I have to have both of those in order to have a linear function. So the first form we're going to talk about is that first one, y equals mx plus b, also known as slope-intercept form. So let's go ahead and write that in. So slope-intercept form is y equals mx plus b. Okay. Now, what does the m mean? Well, the m means slope, right? So we learned about this when we learned about slope, and I talked about the multiple representations there are for slope. M is equivalent to slope. Okay. So the form is called slope-intercept form. So that's going to give us a slope and also an intercept. But not just any intercept, it's going to give us the y-intercept. Okay, so it's going to give us a slope and the y-intercept. Notice that your slope is attached to the x variable. So slope is attached to x. So I also want to mention that the slope is not mx, it's just m. So if I ask you for a slope, just give me the value of m, not mx. The y-intercept is also commonly known as the starting value or the starting number. So we're going to put starting value here. Okay, and that is important, and I'll bring it up in a little bit. Okay, so before we actually get into graphing slope-intercept form, we're going to practice by just identifying the slope and the y-intercept in slope-intercept form. So looking at number 1, remember it's y equals mx plus b. So, and if you're not taking notes, you're wrong, right? You should be taking notes. So I'm going to go ahead and zoom out just so that you can see the form up there. So remember our slope, we're going to identify that first, and then we'll identify the y-intercept soon. So the slope is always attached to the x variable. So our slope in number 1 would be 4. But we always want to write it as a fraction so that we can graph because we want that rise over run. So how would I write 4 as a fraction? Well, that would be 4 over 1. Okay? Your y-intercept is going to be -2. But we want to write it as a point, right? Y-intercept is a point on our graph on the y-axis. So a y-intercept, remember, it looks like 0, number. And so a y-intercept here would be 0, -2. All right, moving on to number 2, we have y equals 1/2 x plus 5. The slope here is going to be positive 1/2, not 1/2 x. Remember, it's just the number attached to it. So the m value is 1 over 2. And that's already as a fraction, so that's pretty good. Okay, now we want our y-intercept, and it's going to be 0, 5. So hopefully we kind of see where our numbers are coming from. Remember, it's mx plus b, so you want to make sure that you see that. And I'm actually going to go back and color code just so that, I'm sorry for all the tapping. We're going to go back and color code just so that we can identify it later. There we go. Okay, So moving on to number 3, now this one looks a little bit different, but what is my slope? Remember, it's the number attached to your x, so it was mx. And here we have an imaginary 1, right? So there's really a 1 there, so our slope is positive 1 over 1. There is a 1 here. There is a 1, so that's our slope. And then what is our y-intercept? Well, there's no number here, so everything else had a number that was next to it, but this one doesn't. So what is nothing represented as a number? 0, right? If I say I have nothing, then it means I have 0. So there's technically a plus 0 here, right? There's technically a 0, an imaginary 0. So that means my y-intercept is 0, 0. Okay? Moving on to number 4, our slope here is going to be, now we want a fraction, so instead of -2, it would be -2 over 1. And then our y-intercept would be 0, -7. So hopefully we were able to recognize this, right? So I'm going to try to highlight for you so that you can see it a little bit better. But the slope is attached to the x. Then number 5, what's our slope here? And if you said 3, you got tricked because remember, slope is attached to the x. So our slope in number 5 would really be -5 over 1. So they tricked you by rearranging it because really mx plus b is the same thing as b plus mx. It doesn't matter the order, so you have to make sure that you're not tricked by the way it's written. And then our y-intercept would be 0, +3. Okay. Last one, number 6, we have our slope here of, now the number in front of the x is technically a -1, so we have -1 over 1. And then our y-intercept here is going to be 0, 8. So this one also had it out of order, but again, you want to make sure you don't get tricked by that too easily. Okay, so we're just identifying slope and y-intercept, and we're doing that because it's going to really help us graph later. Okay. Important note about slope, or really any fractions in general. So I'm letting you know this because you will need this for graphing, so this is super important that you're listening and taking notes. Okay, so -1/2 as a decimal is -0.5. But isn't 1 over -2 the same thing? If you put 1 divided by -2 in the calculator, you're still going to get -0.5. So regardless, these are both -0.5. The only difference is that one of them has a negative in the numerator and the other one has a negative in the denominator. Now these two are really the same thing, okay? They're just the negatives in a different spot. Doesn't mean anything. They're equivalent to each other. You're commonly going to see fractions written this way, where it's a negative and then they'll write it right next to the division bar, and that means the exact same thing. You just basically pick, do you want it in the numerator or do you want it in the denominator? And we'll talk about that when we get there, but I just kind of wanted to let you know about that one. Okay, with the next one over here, we have 3 divided by -4. Well, that's -0.75. Well, equivalently, -3 divided by +4 is still the same thing. So what's really happening, you're basically just changing your sign. So the +3 can be a -3, and the -4 can become a +4. So they're interchangeable, and you can write them either way. Okay? And again, that you can also see this written as -3 over 4, and they just put that negative in the front. So that's commonly how you're going to see it, and you just have to remember that your negative is either in the numerator or the denominator. You just have to decide for yourself. Okay. The next one here, we have +2 over 3. Well, +2 over 3 is the same thing as -2 divided by -3. So if you're just changing the signs for both. So -2 divided by -3 is equal to +2 over 3. They're just written in a different way. So again, you're just changing the signs as you're writing a different kind of equivalent fraction. Okay, so moving on, graph the equations in slope-intercept form. The first thing we always want to do is we want to identify the slope and identify the y-intercept. Okay. So let's identify the slope first. The slope here is going to be 3 over 4 because it's y equals mx plus b, right? M equals the slope. Or, right, we want to write the equivalent form of 3 over 4, which would also be -3 over -4. And why do we write both forms? Because sometimes you can't use one of them, so you're going to have to use the other. So you might as well have both options right in front of you so that you know you have those options. our y-intercept here is going to be positive 4. So 0, 4. Okay, now if you go back to the very front page of the notes, when we talked about slope-intercept form, we have y equals mx plus b. I said m was the slope, and I need to fix this little thing because it looks like I'm attaching it to the x. M is the slope, and b is the y-intercept. And under the y-intercept, I put a star, and I said that's the starting value. So commonly in word problems, the b is the starting value or the starting number. It also is going to be our starting point for graphing. So we always want to start with the y-intercept. So our y-intercept here is 0, 4. A y-intercept is on the y-axis. So make sure you plot it on the y-axis. It's at 0, positive 4, so make sure you plot a point at 0, positive 4 and not negative 4. Okay, now we're going to use our slope. Once you have the point, then you're going to use your slope, where our slope is positive 3 over 4, or negative 3 over negative 4. But you always want to start off trying one of the slopes. So I'm going to try the first slope first. So the first slope is 3 over 4. And remember, when we're talking about graphs, we do rise over run, which means you go up or down first, and then you go left or right. So the rise here would be positive 3, and the run would be positive 4. So if I were to rise 3, I'm off my graph. So I can't fit it on there, so I'm going to use the other slope. I'm going to use this one because I can't fit it the other way. So I still want to start at the point 0, 4, but now for my rise, I'm going to go down 3 because it says negative 3. So I'm going to go down 3, so minus 3, right? And I know it's down because it's negative. And then it says negative 4 for my run. If it's negative, I'm going to the left because those are where the negatives are. So you go 1, 2, 3, 4. And then you plot a point. Okay? Now, I always want at least 3 points, but sometimes you can't fit 3 points, and that's okay. So because I can only really fit 2 points on this graph and I can't keep going, then I'm going to stop. So I did negative 4 there. And I'll show you what I mean. So if I try to go down 3 more, or I do minus 3, and I try to do minus 4, I'm off my graph now. So I just kind of stop, and that's okay. Now once you've plotted your points, you want to draw a line through them, okay? And that line continues on forever and ever, and there's an infinite amount of points on that line. We just chose to only plot 2 of them. Because it's infinite and goes on forever, you want to make sure you draw arrows on those lines. Okay? So that was number 1. All right, number 2. We always want to start by identifying our slope and y-intercept. Our slope here is positive 2, so we want to write that as a fraction, 2 over 1. And we want to write it as a fraction so that we know definitively what is our rise and what is our run. Our y-intercept is going to be negative 4, so 0, negative 4. Now for the slope, I do want to also write it in its equivalent form just in case I need to use it. So negative 2 divided by negative 1, right? 2 over 1 is positive 2, and then negative 2 divided by negative 1 is still positive 2. So you want to make sure they're equivalent to each other. I also forgot to mention this earlier, but looking at our slope earlier, we had a positive 3 over 4. That's a positive slope, right? So that means our line should also be positive, and it is. The line is in a positive direction. So that's a way you can check yourself to make sure if you've graphed it correctly. So here I have a positive slope. I have positive 2, so my line here should also be positive. So we'll graph this and see if we did it correct. So we're going to plot our y-intercept first at 0, negative 4. Remember, the y-intercept is on the y-axis. And then we're going to use our slope. And I'm going to go ahead and use this one first. So I'm going to go rise. Remember, rise over run. So you rise up 2. Right, because it's positive 2, and then you're going to run positive 1, which is going to be to the right. So plus 1, and then you plot a point. Do I have room to keep going? Yes. So you're going to rise 2 more, and then run another one. So you could really keep going on forever, but we only really need 3. So I like to have a minimum of 3, and if you don't do a minimum of 3, then I'm not going to give you full credit. So make sure you at least do 3. Here's another thing. You could always use the other slope as well. So let me do negative 2 over negative 1. So you want to start back at the original point. So our original point was at the y-intercept of 0, negative 4. So let's start back there. Our rise is going to be negative 2, so we're going to go down 2. so minus 2. And then it says -1 for our run. So that's going to be to the left, and then we can plot a point. So do you see how it's still in a line? Remember, these are linear functions, linear equations. So if it doesn't make a line, you probably didn't graph it correctly. So just make sure you are being very careful as you graph. You draw a line and make sure you put those arrows in. All right, moving on. Number 3. Our slope here is -1/3. Now remember what I said. If it looks like this, you need to pick. So it can either be in the numerator or it can be in the denominator, okay? So that means the same exact thing. So the negative in the front is just saying, hey, there's a negative sign. You decide where you want to put the negative because it doesn't really matter. So our slope here is -1/3 or 1/-3. Okay? And then our y-intercept, did I call that the slope? That's the slope. If I called it something else, I'm sorry. The y-intercept is at +2, so that's going to be the point 0, 2. So we're going to go ahead and write or plot a point at the +2 y-intercept, so that's going to be on our y-axis at +2. And then we're going to use our slope of -1/3. So again, you pick one, and if one of them doesn't work, then you move on, right? But you can use either. It doesn't really matter. It will still follow the pattern of your line. So the first thing it wants me to do is rise over run. So the rise is going to be -1, so I'm going to go down 1. And then it says run +3. So positive would be to the right. So 1, 2, 3, +3, plot a point. Okay? And then just to be different, let's go ahead and use the other slope too. So let's start at the beginning again at the y-intercept of baby blue. So we're going to start and we're going to go rise of up 1 and then run -3. So that's going to be to the left. So 1, 2, 3. And then we plot a point there. So again, you can do either direction. I just need 3 points. So if you want to just keep going in the same direction, it doesn't matter. If you want to use both of your slopes, you're also allowed to do that. So it does not matter to me. Okay, and then make sure you draw those arrows and your lines because that line does keep going. All right, moving on to number 4. Now, don't get tricked by this one. So our slope here is -4 because they flipped it around on us, right? Instead of mx plus b, they did b plus mx. So our slope here is going to be -4/1 because we want it as a fraction, or 4/-1. Again, you're not always going to use both, but you can use both. Our y-intercept here is at +3. So let's go ahead and graph that at +3. And then we're going to use our slope. So we're going to go down 4. So 1, 2, 3, 4. So -4, right? And then we're going to do our run. Oops, I forgot to do this in a different color. Green. Okay, and then we're going to go run 1. So it's going to be a positive one, so it's going to be this way, and then plot a point. And then I'm going to do the same thing again because I want at least 3 points. So this one I'm just going to keep going in the same direction. So I'm going to go down 4, 1, 2, 3, 4, and then to the right 1 because it's a positive 1. So if I check, this line is going in the negative direction. My line is negative, and my slope is also negative. So you want to check to make sure your slope and your line match up each other. With number 3, our slope was -1/3, right? It was -1/3 here, and our line was negative, so that checks out. For this one here, our slope is +2, and our line is positive. So you always want to make sure that they match up. Okay, moving on to number 5. This one looks a little bit different because you're like, whoa, where'd all the numbers, where'd all the x's go, where'd all those things go? Well, this was actually really simple, but it can be really easy to mess up at the same time. So here it's a little bit different, right? You only have a variable and you only have a number. Okay, now what is that variable that you have? You have a y equals. Because it's a y equals, it's going to tell you, look at the y-axis. So if you want to make a note to yourself, look at y-axis. How do you know to look at the y-axis? Because it says y equals, okay? Now if it said x equals, then you look at the x-axis. So the y-axis, it is labeled for us, but if you don't know where the y-axis is, it is this one, because it has a y next to it. It is the vertical axis, okay? Now it says, let's go ahead and just graph that too, so for now. Okay, so we're looking at that purple highlighted axis. Then it says y equals 3. So on our y-axis, I'm going to plot a point at positive 3. So where is positive 3 on my y-axis? That is right here. And how do I know it's positive? Because it says y equals positive 3 over there. Okay, now you know how sometimes I draw graphs for you and I draw them like this, and then I draw you little tick marks that look like that? Yeah? Okay, so let's plot a point at y equals positive 3. Now, where are the tick marks going? The tick marks are going side to side. So you're going to draw a line that goes side to side as well, like this. Okay? You're going to follow the tick marks. So here, our blue lines are here. So we're going to follow our tick marks, and it's just one giant horizontal line. So what is this? It's a horizontal line. And what's the slope of this? Well, the slope of this would be, remember it makes a z for 0, so my slope is 0. What's my y-intercept? My y-intercept here is 0, 3. It's a horizontal line. Okay, so let's retrace our steps, right? It's y and a number. So if it's just a variable and a number all by itself, it's going to either be a horizontal line or a vertical line. So this says y equals 3, so you want to look at your y-axis and you want to plot a point at positive 3, and then you identify your slope and your y-intercept from there. Okay, so moving on to number 6. So here I forgot to ask for the slope and the y-intercepts. Let me go ahead and put those down, so m and b. Okay, so this one says y equals -2. So I'm going to look at my y-axis because it says y equals, and then it says -2. So I'm going to put a point at -2 on the y-axis. Okay, now you want to follow those tick marks. So you see that blue tick mark that's going side to side right here? So you're going to follow it, and you're going to create a line that goes through the entire thing. This is another horizontal line. So what's my slope here? My slope again is 0. Z for 0, right? And then, what is my y-intercept? Well, my y-intercept here is 0, -2. Okay? So these aren't too hard to graph. You just have to remember the little tricks that I'm showing you. All right, so for number 7, we have x equals 4. So this one has a variable and a number, except the variable this time isn't y, it's x. So here we're going to look at the x-axis. So you're going to look at your x-axis, so that's this one right here. Okay, our x-axis, so I'm going to go ahead and do this, look at x-axis, and you're going to plot a point at 4 on the x-axis, so at positive 4 on the x-axis here. Okay, and then you see how these tick marks, they're going up and down. You see these blue tick marks like this, so you're going to go up and down and follow that line. The most common mistake I get is that you've plotted this point and then you just do this, which is not correct. So you want to follow those tick marks. Whoops. So you draw arrows because they keep going forever and ever. Okay, our slope here, if you remember, is, it makes a U with the axis, so it's going to be undefined. Okay, and then what is our y-intercept here? Remember, the y-intercept is on the y-axis. But this line is never going to intersect the y-axis, so we don't have any y-intercepts here. We have none. What do we have instead? We have an x-intercept. And just for fun, the x-intercept here is 4, 0. Now, I didn't ask for it, but just for fun, we want to identify it, right? Okay, with number 8, it is x equals a number, so it's going to be on our x-axis. Remember, we're looking at whatever, if it's by itself, you just want to look at that only. Okay. So here, it's the x-axis, and it's telling us to look at -3. So we're going to go on the x-axis at -3. Okay? And then we're going to follow those tick marks, so make sure you're going up and down on this one. The slope on this one, again, is undefined. And the y-intercept here, we don't have one. It doesn't cross the y-axis, so we have none. Okay? So you only have none if it doesn't cross. But that is it for graphing slope-intercept form, and this is when the equations are already in slope-intercept form. So eventually we'll have to move them in a slope-intercept form, and that's the next lesson. But when they're in slope-intercept form, this is how you would graph them. If you have any questions, please feel free to come in and ask.